Unit 6, Section 1, Video 3. Here we're still going through a few more examples, and we just have a little bit continuation from example 3, and it asks us to look in simplest form what is the ratio of the area of NPSR over the area of MNQR. So this is just to say it doesn't really matter what order you put them in. So we found out that the area of NPSR was 128, and then the area of MNQR was 256. And then if we simplify that down, we can get that as 1 over 2. And like we said before, it's half as big. The area of NPSR is half as big as the area of MNRQ. Moving on to example 4, triangle ABC's angles have the ratio 3 to 3 to 4. So what's the measure of each angle? Okay, so that's to say a picture always helps. So if we draw a picture of some random triangle, ABC, and it's saying that these angle measures have the ratio 3 to 3 to 4. So that's to say that 3 times some constant, 3 times another constant, and then 4 times another some sort of constant would give us the measures of those angles. And that's to say x could be 1, or x could be any other number. But we have to remember the angles in a triangle do have to add up to 180, so we could actually solve for what that x should be. So we set up an equation to solve for. So we know 3x plus 3x plus 4x has to be 180. So we know x can't be 1, but it has to be some number. So please simplify. 3x plus 3x plus 4x is really just saying 10x equals 180. And if we divide both sides by 10, we get that x equals 18. And then we can solve for each angle measure by plugging our x back in. So the two angles that are 3x big, we know that they are 3 times 18, which we get to be 54. And then 4 times x is 4 times 18, and we get that that is 72. So that's saying that the measures of the angles are 54, 54, and 72 degrees. And we can check to make sure that those add up to 180, as they should. And the next question is rectangle DEFG's length and width have the ratio 3 to 5 and an area of 540 square units. So what is the length and width? Once again, if we draw a picture, so we have this rectangle, and the length is 3x, and the width is 5x. So that's just to say that if we have some number, 3 times that number will be the length, and 5 times that number will be the width. And we know that the area is 540, and since we know that area equals length times width, we can set up our equation to solve for what that x is. So that's to say that 540 equals our length, which is 3x, times our width, which is 5x. We can simplify that to 540 equals 15x squared, because we have to think we have 3 times x times 5 times x, which we can kind of combine things to be 15x squared. Divide both sides by 15, so we get x squared equals 36. We do the square root of both sides to get x equals 6. Once again, we're not done quite yet. We need to solve for length and width, not just x. So we know that length equals 3 times x, which is 6. So our length is 18. And our width equals 5 times x, which is 6. So our width must be 30. So those are our length and width. Moving on to example 5. Jenna and Josh each worked on this problem and who is correct and why. So this is just to get you to realize the importance of distributing and realizing exactly how to go about the algebra, because these are really common mistakes that we see. So our original proportion is 3 over 4 equals 2 over x plus 2. So Jenna's work and John's work. Now, if we look at Jenna's work, it looks like the way she wrote it, she solved it correctly, but she got a different answer than John. So we have to figure out which one of them started the problem correctly. And we see an error right away in Jenna's work, right here. Because we know that x plus 2 is its own piece of the puzzle, so we have to keep those parentheses around it and then distribute the 3 like John did here. So this is a mistake, which led to a wrong conclusion. So we have to be very careful in how we write it and how we solve it so we don't make mistakes like that. So let's practice a little bit. If they ask us to solve this proportion, we would use our cross products so that 4x minus 5 and all of that times 6 would equal negative 26 times 3. Now I need to distribute, and so a lot of you are probably used to distributing from the front, so I'm actually just going to rewrite it so it's a little more obvious. And I could just solve for negative 26 times 3 right now, which I know is negative 78. And so I'm going to distribute this. 6 times 4x is 24x, times 6 times negative 5 is negative 30. Add 30 to both sides, 24x equals negative 48. Divide both sides by 24, I get x equals negative 2. One more practice problem. Cross. In this one, there's actually a little typo. This denominator actually needs to be 1. So it'll just be better practice for us is that is a 1. So we're going to cross multiply, and we have 4 times x plus 2 equals 2x times 1. And it doesn't really matter which one I do first, if I do 2x times 1 equals 4 times x plus 2 or the other way around. They're both equivalent. And so I start, and I have to remember I have to distribute, so I have 4x plus 4 times 2, which is 8, equals 2x. I'm going to subtract 4x from this left side, and that'll give me 2x minus 4x, which will end up being negative 2x. Divide both sides by negative 2, so I get x equals negative 4. So when it says solve the proportion, it's really just looking for what the value of x is. Now, there's one more theorem on the back of this page, and I'll do that in the next video.